The next topic is mesh analysis. Here I'm going to start with an example. What is the advantage of mesh analysis? Uh, since in our previous videos we already learned about nodal analysis, sometimes it is easy to solve by using nodal analysis, sometimes it is easy to solve by using mesh analysis. Both of them are useful to find any quantity like voltage, power, or current in any element in a circuit. Now, the main disadvantage of mesh analysis is sometimes you may end up with more number of equations. So n number of equations, so n number of variables. Solving more number of equations is little difficult. So here I'm going to start with the basic example. Before going to the mesh example, I'm going to define a loop. Mesh analysis is also called loop analysis. Loop is nothing but start traveling from one node and reach the same node without touching any element more than once. So if you look at here, I'm starting from here and reaching the same node, okay, traveling through all this way. Okay, this is called loop. And here is another loop, and here is the blue one is another loop. Okay, there are more than 3 loops. I can call this as also a loop. Okay, as long as your starting point or starting node and ending node is same and you're not touching any element more than once, that's called loop. Mesh is nothing but the shortest loop is called mesh. So if you look at this blue one, okay, so starting at the same node, reaching the same node in the shortest path, that's called a mesh. I can call mesh as a loop but not a loop as a mesh. So at this point, I mean, don't worry too much about it. We're going to do mesh analysis. So we're going to do the shortest loops. Basically, it's up to you. You can choose the long loops too to solve, but for convenient, I'm going to do the shortest loops. In this example, we have to find ix. What is ix value? That's the goal. Okay, so here what I'm going to do, I'm going to find step 1, find number of loops and assign loop current. So here I'm going to say this is my loop 1, okay, or mesh 1, doesn't matter, you can call loop or mesh. Mesh 1, I'm going to assume that mesh current as I1, and mesh 2, so I'm starting at this point, going through all these 3 elements, 8 ohms, 10 ohms, 24 ohms, reaching back, that is mesh 2. I'm going to call this current as I2, and mesh 3 is right here. I'm going to call this current as I3. Okay, I3. Now if you look at loop 1, now I'm going to redraw loop 1. So if you look at loop 1, these are the 3 elements. We have 64 volts. I'm saying there is I1 current passing through this, but at the same time there is I2 current passing here. Okay, so if you look at what is the look at the circuit, what is the current flowing in 4 ohms? I can say the current flowing in 4 ohms is I1. When it comes to current flowing in 24 ohms, this is 24 ohms. What is the current flowing there? I1 current is coming down and I2 current is going up. I'm going to call this as I1 minus I2. Okay, now mesh analysis is related to the KVL, Kirchhoff's voltage law. So according to KVL, in any closed circuit, okay, let me write down KVL. In any closed circuit, voltage gain equal to voltage drop in any closed circuit. In a closed circuit, okay, in a closed circuit, voltage gain equal to voltage drop. That's a simple KVL equation. So if you look at this this loop, Okay, in a closed circuit, we're saying voltage gain equal to voltage drop. Now, how do you know which one is voltage gain and which one is voltage drop? If current is entering the negative terminal, take that as a voltage gain. If current is entering the positive terminal, take that as a voltage drop. So how do you define voltage gain or voltage drop? If current is entering into negative terminal, take that as a voltage gain. If current is entering into positive terminal, take it as a voltage drop. So here I can say I1 is entering into negative terminal. So here this is voltage drop. So this is V drop. Now for the resistor, I don't have a positive sign or negative sign. So what we need to do, we need to assign positive and negative signs for each and every element. So here, so when I draw the loop current, okay, basically what I'm doing here, I'm start walking from there and reaching the same node, passing through all these three elements. The resistor always consumes energy. Basically it consumes electrical energy and it gives you back either heat energy or light energy. Okay, so it always consumes the electrical energy. So whenever you are traveling, you need to assign positive and negative signs according to your current direction. Okay, so when I'm in loop 1, I'm going to follow loop 1 current direction. I'm going to assign all the positive and negative signs according to my current direction. So here what I'm going to do, I'm going to assign, that's my positive, negative, positive, negative. Now loop 1, apply KVL. Loop 1, apply KVL. So here, what is voltage gain? That 64 volt is a voltage gain. Okay, or so I can say that equal to 64 equal to I don't know which one is voltage drop or gain, so I'm going to make a little bit distance. Now is this a voltage drop or gain? That's a voltage drop because I'm entering through positive terminal, so that is equal to 4 times I1. Okay, V equal to, according to Ohm's law, V equal to I times R. That's the formula I used, I1 times R. Okay, is this a voltage drop or gain? That's a voltage drop, so plus 24 times I1 minus I2. Okay, this is the equation in loop 1. Another way of simply writing this equation, once you assign, if you are entering into negative terminal, take that as negative, entering positive terminal, take that as positive. So I can rewrite this as minus 64 plus 4I1 plus 24 I1 minus I2 equal to 0. So all I did, I moved this 24 into the other side. That's one way to look into it. Or another way is, when you are entering into negative terminal, take that as a negative number. Entering into positive terminal, take that as a positive voltage. So if I simplify this, I will end up with 28 I1 minus 24 I2 equal to 64. This is my loop 1 first equation. Okay, now loop 2, again apply KVL. Okay, now when you are in loop 2, assume that loop 2 current is larger than any other current. So what I'm going to do, according to my I2, I'm going to assign positive and negative sign, positive, negative, positive, negative. So I'm ignoring these previous ones, positive, negative. For loop 2, I'm assigning again according to my current direction. Okay, so this is a voltage drop, that's a voltage drop, this is also voltage drop. So sum of all the three voltages must be equal to 0. So loop 2, when it comes to loop 2, apply KVL. So it's 8I1, I'm entering the positive terminal, so positive 8I2 plus, when it comes to the 10 ohm resistor, what is the current passing through this? So I2 is coming down and I3 is going up, so I can say I2 minus I3 is coming down. So plus 10 times I2 minus I3 plus, I'm entering the positive terminal, so that's a drop, 24 times. Now if you look at 24 ohm, so here is my 24 ohm, I2 is going up and I1 is coming down. I'm assigning this positive and negative sign according to my I2 current. I'm assuming I2 is larger than any other current. So it's going to be I2 minus I1. So the current going in this direction is I2 minus I1. So the reason behind, I always assume that loop current is higher than any other loop current because my equations are going to be simple. Every time you will see I2 minus something. So I2 minus 0, I2 minus I3, I2 minus I1. So if I rewrite or simplify that equation, if I simplify this equation, I have 10, not 10. So here is loop 3. I wrote the loop 2 equation. This is the simplified loop 2 equation. That's the second equation. When you look at loop 3, here is my loop 3. So according to my I3 current, I'm going to assign positive and negative sign. You don't need to do that for voltage source. It's already given always. For voltage source, it's always given. Either you will see a voltage source with circle plus or minus, same as a positive node and negative node. So it's a battery, representing a battery basically. The long line is positive, short line is negative. So that's already assigned. You don't need to do that again. So this is positive and negative. Now what is the current passing through this 10 ohms? Now I'm dealing with I3, loop 3, I3 current. So I'm assuming I3 is larger than I2. So I can say I3 minus I2 is going up. Okay, so that's how, based on this current, I assign this positive and negative signs anyway. So start walking from one point and then reach the same point. So 5 times I2, because I'm entering the positive, take that as positive. This is, I'm entering positive, take that as a positive, plus 10 times, sorry, this is I3 not I2, 5 I3 plus 30 plus 10 I3 minus I2 equal to 0. So basically minus 10 I2 plus 15 I3 equal to minus 30. Or I can say 10 I2 minus 15 I3 equal to 30. This is my third equation. Now you might have a question, how come that's a battery source? How come that is, I said if you're entering positive terminal, take that as a voltage drop. How come that's a voltage drop? It's look like a source. So how come instead of supplying energy, how come it is taking energy? We don't know. It might be supplying, might be taking. But the taking is nothing but basically it is recharging. Those batteries are recharging. So that's a possibility. Or it might be supplying. We don't know. I just assumed current is flowing in this direction. But at the end, you may end up getting I3 as a negative number. So that indicates that the real current is flowing in the opposite side. So here I have 3 equations, 1, 2, 3, and 3 unknowns. Once I find those 3 unknowns, we can find the needed parameter Ix. Okay, how to solve those 3 equations, 3 unknown? There are many ways. You can use the matrix format or you can use the substitution method. I'm not concentrating on how to solve those 3 unknown 3 equations, but I will give you the answer in a second. So as I mentioned, I'm not going to solve them, but I end up finding I1 equal to 4.309 ampere and I2 equal to 2.361 ampere and I3 equal to minus 0.425 ampere. So here, as I told you, I3 you end up with a negative number that indicates that that source is supplying power instead of consuming energy. So our goal is finding Ix. Ix is nothing but the current flowing in the 10 ohm resistor. But look at the direction. Here the current Ix is flowing towards down. So what is Ix? If Ix is flowing down, it must be I2 minus I3, because here is 10 ohm. My goal is finding Ix. Okay, but I said I2 current is, I assumed I2 is flowing in this direction, I3 is flowing in this direction. So to get Ix, I2 must be larger than I3, because I2 and Ix are in the same direction. Okay, so I2, I have 2.361 minus I3 minus 0.425. So that is the current passing through that branch. So Ix equal to 2.786 amperes. I'm going to solve more examples in next videos. Thank you.